Hello, good afternoon. Welcome to the second of the food4Rhino webinar series. I hope you had a great summer. And I'm Carlos Perez from McNeel Europe. We have the pleasure today to have with us Peng Wang from PedSim. He will introduce us to a new pedestrian simulation plugin for Grasshopper. And he will start with an introduction, then some case studies, and then a live demo. He will also differentiate between the free version you can find on food4Rhino and PedSim Pro. And during the webinar, feel free to use the chat you can find on YouTube, because my colleague Carla Sologuren is also there. She will be able to answer some of the questions live. And the rest of the questions, we will collect them for the end of the webinar, and then Peng Wang will be answering this. So thank you very much, Peng, to be here from New York City. And please, you can start with your presentation.
Okay, let me go full screen. Okay, hello everyone. This is Peng. First, I'd like to thank McNeel and thank Carlos for giving me this wonderful opportunity. I have been wanting to show more people the PedSim plugin for a long time. So in this video, I will show you two plugins, PedSim and PedSim Pro, but I will focus on PedSim because it has been available since 2017 on food4Rhino. And PedSim Pro is relatively new. It only have been available this year. It is more advanced, but they are very much same series, and they do similar things. So what does PedSim do? PedSim is, to put it simply, it is a pedestrian simulation plugin in Rhino and Grasshopper platform. It is fully integrated with Rhino and Grasshopper, meaning that you don't need a separate user interface, and you don't need to learn different functions and buttons. You can get started very quickly. And also you can utilize Rhino and Grasshopper's analyzing capacity and all the great functions that they provide. You can visualize your data very easily. And the simulation model that you are building will be very flexible. It will largely depend on your need and your capacity. So PedSim is a two-dimensional, it's a 2D engine, but you can visualize it in either 2D or 3D, as you can see here. It is real time. So meaning that you can visualize it, you can simulate, and in the same time, you can manipulate most of your parameters and see the result in real time. You can also monitor your simulation and do your view manipulation, your visualization in Rhino. So real time, because it is relying on Grasshopper timer. So if you connect the Grasshopper timer to the PedSim engine, you will see it real time. Otherwise, you can still perform like a single frame simulation, but that's how it is realized. So in terms of scale, PedSim works from a small scale to a very large scale. So you can see here it works from the room scale to urban scale. And it is also, it features a very simple physical engine, but it is very effective in simulating simple behavior between different single agents. So it is easy to understand. What is it best for? It is best for scenario where you want people to walk and take few short stops. And for example, you can do simulation in a shopping environment, in an office environment, or even exhibition that's interior, or in the exterior, you can simulate your landscape design, or urban design, or general public space. it may not be best for a very dense crowd or evacuation simulation, but that will likely improve as we put more features and functionality into PedSim Pro. So you can expect some improvements there. So within PedSim, there are some basic elements. There is a basic, the simulation scene, we call it map. So the map basically is a scene in your Rhino environment, but it only takes two types of Rhino geometry. One is the polygon, one is the points. So the points makes the gates and the targets. The, so at this point, maybe I can switch to my first demo here. So here you can see it's the same as what you saw there. So the black two dots are, we call gates. So people are generated from the gates and will disappear at a gate. So in between, so they always go from one gate to the other gate, and in between they can visit their target of interest. This is optional, and this is relying on their vision. So let me start it. So you can see that people have like a field of view, right? That's the gray zone. And if they see the target of interest, they will go there. Otherwise, let's see a new person. New person, when it starts, it will find a shortest route from the start gate to the destination gate. So that you can see. So the vision is an optional thing. You can use different types of vision. Here I have it, have a preview here. You can also disable the preview. And also you can connect a different vision to the person as well. So this component shows that. Okay. So that's the very minimum of simulation here. So we can summarize the agent's behavior here. So people move from start gate to destination gate. If they see a target of their interest, they will go to that target, stay a while, and reroute to the destination gate. The interest and how long they stay, all these kind of things you can customize within your Grasshopper definition. So how do they find their way? This is relying on something we call a route graph. So different from many other simulation tools, PedSim doesn't force you to draw the route. You don't need to explicitly model where people can travel, but you model the obstacles, so where people cannot access. Back to this example, so behind what you see here, if you turn on the preview of the engine, you can see this. You can see this we call a route graph, where the green lines are the edges and the points are the vertices. You can notice that the vertices are all offset from the obstacle, so it's generated automatically. You can imagine that people don't need to look for their way like everywhere. They only need to look for it within these edges. So if you go back to here, so in the beginning, they will find the nearest visible vertex, and then from there, it will use the edges to form their shortest route. And in the end, when they see the target, they will just directly go there. So this will guarantee they always traverse the shortest route. Okay. So in an even smaller scale, so how do people move? So people move, people are driven by forces, basically. So this is in the very tight scale, while we use a physical engine, so everything is first a force. So the way people are driven by a target, we call a target force, and we also get people um, avoiding each other. That we use like different forces, like repulsion. We have two repulsions between people, which are a person repulsion and anticipatory collision avoidance force. And we also have the repulsion from a person to a wall. So these repulsion forces are proportional to the distance, whereas the target force you can specify. From the force, we can use this Newton's formula to get the acceleration, and from acceleration, we can get the velocity, and then we can get the displacement. So that's how PedSim works in general. There are a few simplifications, of course. So firstly, PedSim is a little bit more simplified than PedSim Pro. In PedSim Pro, you can specify the mass of a person. You can also control the speed directly. Uh, but in PedSim, we simplify that so you don't have to specify the mass. It's always one, so you have a direct control of the target force or the acceleration generated from it, but you don't have a direct control of the speed. Um, this will You will find this to be improved in PedSim Pro. So what are the strengths from this physical engine? First, it has a good avoidance behavior. So if you see some video that we released early on with this anticipatory collision avoidance, we can get a very realistic effect. So people almost never bump into each other, and they will avoid each other uh, like sometime before they collide. This time you can set. Uh, but in the examples you will see, we set it to between 1 second to 2 seconds. So when collision are likely to happen within 2 seconds, people will avoid each other early to get a smooth movement. And this physical engine also makes sure that we can get a kind of realistic simulation when the density is very low or it is a medium. However, there are some limitations. So if the density is very big, so if the crowd is very large or the people's distance are very small, like people are trying to get through a tight passage or a tight gate, that may not generate a very realistic result. However, we are working on some advanced features in PedSim Pro. So like collision detection, and the way we handle collision will make sure that people never have overlap between with other neighbors. Okay, so lastly, maybe I will still mention, so people will expect, some users expect more advanced agent behavior, like some social interaction, like grouping or even queuing in a line. However, we don't have that now. We don't have it yet. We have some planned features that will gradually move into that field. But for now, we are generally relying on very simple interactions to realize more complicated behavior. So here is my second example. This is based on a realistic shopping corridor here. It is very narrow. So I hope this can show you where the tight physical engine has application. So let's see it here. So we can see the corridor is fairly long. It's like some 30-meter long, but it only is like 2 or 3 meters wide. Let me start it. Okay, here you can see like there are two types of person. Some people will stop and shop, do some shopping along this shopping corridor. Some people will just pass by without doing any shopping. And if people are doing shopping, like the one, this one, oh, I moved it. But you can see even I drag it, it still doesn't affect it. So it's real time. Um, so the bottom one is what's happening in reality, and the top one is my tweak to this little map. So what's happening here? You can see people may block the traffic, right, when they stop and do some shopping. So I thought maybe if I tweak the edge of the shopping counters and make some notches, and when people stop, they don't block the traffic. So I tested it out, and so you can see the orange and blue color indicate the speed where people travel. So the more orange, the more red, that indicate this area people travel at a higher speed, and vice versa. So in general, you can see a pattern of how fast people move on the map. And also we can see it in 3 dimension. So it looks something like this, right? So if you look a little bit closely, you can see that people always avoid each other effectively. So they almost never bump into each other. And if they don't pass, they can even wait for a while. Okay, so what does this tell us? How do we get an evaluation? Which one is better? Um, that we can export the total travel time, right? That's like my intuition at the time. So I compare how fast people travel from the start to the end, and got this uh, little diagram. So the gray is the straight version, and the blue is the notched or dented version. You can see for the non-shoppers, the dented version will save some time for them. So because the notch will mm, basically accommodate people doing shopping. So for the non-shoppers, they can travel faster, but for the shoppers, you can see on the right, they spend a little bit more time on the dented map. So that's our conclusion on this map. And this very simplified scenario can tell us that PedSim actually can help you compare your design options or your basically your spatial design without you relying on other information. The pedestrian simulation itself is useful when you are designing some tight spaces like this. Okay, so if you want to get a little bit deeper and if you want to do your own modeling, you will need to understand this. This is PedSim's modeling logic. Basically from the left, it is basically an abstraction of the grasshopper definition itself. From the left, you can see it only takes two types of Rhino geometry, points and polygons. The gates and targets, they are very similar objects. And from the gates and targets, you will generate basically from this gate and targets and obstacles, you will already form the map, but you will also need to inform the user about the agents. So that is done through the person templates. The person templates is like at the core of your modeling process. If you want to model some complicated scenario, you will need many person templates. And Grasshopper, luckily, Grasshopper give you a way to generate multiple person templates with only a few components. And on the right, you will see some like post-processing function. This part is only a simplification. It's generalized. In reality, you don't need to stick with it. You can invent your own post-processing and do something more. From this one, we take a step further and we developed PedSim Pro. PedSim Pro's logic is like this. So you can see the biggest difference is on the left. We no longer have different targets. We only have stops. But the stops, we use like two types of stops. One we call room, where people can get into. If people get into a room, you no longer see it on the map. It basically disappear temporarily on the map. Um, and Whereas a stand is basically the same as what PedSim has. People will still stand there when they visit a stand, but they are essentially the same. So we made them like a stop in the same way, so you can plan their travel on the map by specifying a series of stops, no matter it is a room or a stand. And we also use person profile to have a collection of parameters for a person that you can reuse. So for example, if you have some people that are have a tendency to travel faster or travel slower or wait for longer, then you can generate person profile for them. Person profile basically doesn't concern their travel route. That is handled by person templates. That's always person template. It is at the core of the simulation. Okay. So there are some improvements that I listed here. PedSim Pro will also be expanding constantly. So if you check out PedSim Pro after a few months, I think we will be updating it. So PedSim Pro features from the very beginning, so current version is 1.0. You can get those features on top of PedSim. You can have multiple stops, like this diagram. You can have a room versus stand. Uh, you can have transparent obstacles like this one. If you visit pedsim.net, the first thing you will see is the animation of this scenario where you can people see through all the obstacles, but they still travel outside of the obstacles, which are the tables. And you have direct speed control. You have improved the target selection that I will demonstrate later. You will have person profile. Um, what we are planning to develop are some advanced features that will help you to do some social distancing studies. For example, you will have collision detection, and you can specify separate entry and exit for a room. You can have speed limit that will make people's travel more realistic. And you can also expect more analyzing features that will help you understand how PedSim Pro function at the core. But the thing you see here at the bottom, they're not there yet. If you want to see more, you can check the YouTube channel. You will find some examples there. Okay, so the third example I have is for PedSim Pro. It is this one. Here you see it's a little bit more complicated. It basically is a museum lobby. People enter from here and eventually they will go to one of the three museums. But when a typical person, you need to purchase a ticket before you get into the museum gallery, right? And it is not an interest, it is not optional. You must go there, right? So that will require a planned stop. So that is done through here. We have 3-person template. If I turn it on and off, you will see this red arrow indicate 1-person template. Each circle is one stop. You have a starting point and 1, 2, and 3 stops. So that is the same for the other 2. Yeah. So let me start this. So you can see the people will follow this person template. However, it is a little bit more complicated because some people may be interested in the information desk. They may grab a map on their way. So you can see some people will access there. There are 4 accessing points, and each point will accommodate 1 person at a time, but you can wait there if you want. So you can see there are at most 2 people waiting there. If there, yeah, sometimes there are 3. This is set by uh, a timer or a timing parameter in person. So you can decide how long you want to wait. And if the queue is too long, people may first go to buy ticket, and then they can come out. And when they see the queue become shorter, they can still go and visit. So if you see closely, yeah, some people will get away from this red line and get to this information desk here as well, like this one, yeah. So you can see that even with this very simple behavior, you can get this intricate pattern of movement, something you want to have when you simulate a rather complicated scenario. Maybe you will have like 10 of these or 20 or something, right? That will be a good basis for your simulation. Also, since I mentioned the social distancing, we already have something close, but it's not that good yet. So please pay attention to the people here in the middle. And if I set the uh, repulsion force threshold to 5 meters here, you can see the people will move away from each other, right? So they will form a larger distance. So with this very simple physical engine, you can already get something like social distancing or like some basic social behavior. If I disconnect, you can see people get closer again. Okay. Yeah, lastly, I'd like to show you a good example from one of our users. They are the UDAI based in UK, and they use PedSim as part of their facade optimization process. You can see what they use in a realistic project, in a real project, basically. So this has audio, but you will not be able to hear the audio. Please visit their website to check it out. Here you can see it's an office tower, and their process is to do a pedestrian simulation to figure out where people accumulate, where people frequent in the plan of a typical floor. And they will also analyze the sunlight, the direct sunlight shining through the facade onto the floor. And that will be a basis for the comfort level, right? And they can optimize the facade so that the people will be more comfortable in places where they frequently travel to. So here you can see on the left is a pedestrian map, on the right is a daylight, and they overlay them and optimize the facade to get a better result. So for the latter part, I still don't fully understand the details of this process, but you can see they have like 2 parameters they use as a target and optimize the facade so that the 2 parameters can gradually improve. Okay. So please check out their website here. I think this is a great example because it combines PedSim analysis with another layer of information. Here it is environmental information. It is the sun, the radiation exposure. And you can imagine for your project, you can use another layer of the information and use PedSim, the pedestrian information or the visitor information as part of your design process or analyze process. Okay, that is basically my presentation. Carlos?
Yes, thank you. A very, very nice presentation. I hope people enjoy it. We have more than 170 concurrent viewers. And yeah, it was fast, but I think we got the idea. And now there are some interesting questions on the chat. Maybe I can pass this to you. For example, this was made Yudha. He asks if there is a feature in PedSim Pro to simulate social distancing. You are mute now. No, I cannot hear you. Maybe now
yes. It's good. Okay,
yes,
okay.
Yes. So question, if there is a feature to simulate social distancing, I don't know if it's just to set 2 meters distance or there is anything else there.
Yes. So you can see that we have an optional component called settings. This settings, if you connect it with the engine, you can get a lot of control. Within these control, there are groups. So you can see these four are controlling the repulsion forces between people. And like I demonstrated a while ago, you can basically use this one, the P threshold. This controls the range of force, basically. If people our distance are closer than this value, they will experience this repulsion. If their distance is greater than this value, they will not experience the repulsion. So in this way, you can control how long the distance they should keep. It is it's not compulsory distance. You can see it again. If I connected those people here, they will tend to keep larger distance, but it is not a compulsory process. So it is kind of a soft control. However, if you check out the PedSim Pro website, here you can see these 3 new releases where we demonstrate our new approach in PedSim Pro, where you can get improved results. Yeah. Maybe I can even show you a little bit here. I know some of you may not have seen it. We haven't put it on our website because it's not an official release yet. So you can see this is a shorter distance. It is a 1 meter repulsion threshold. Here it is 2 meter. You can see the pattern will change, right? This is already something it's a little bit better than what you saw in the live example, because this has some new features. Basically, the biggest change is the speed limit. You can see on this map, we have the speed limit, and people will be more consistent in the speed they travel. So that's it.
Nice. I think we will also add a link to your YouTube channel on the webinar. By the way, this webinar is being recorded, so we will make it available on our food4Rhino webinar series playlist. There are more questions. Well, you showed this already. And yeah, Ahmed Umberen also asks if there is or can be an option to have a side tendency for the agents when they face each other.
A side tendency?
Yeah, I guess he asks, it's not the same to meet face to face than back to back. I think this is the question.
Okay. Yes. Actually, we have something like that. If you see this example, I think the answer is yes and no, right? So people have a front and back. Um, as you can see in this example where I can turn on the field of view, right? So they have a direction when they travel. That's the same direction as their traveling speed, velocity, basically. Um, so they have but however, this direction, this field of view you see here, it is not used to identify other agents. It is only used to identify the targets. So um, that's, I think you can keep that in mind, and maybe that's a limitation of PedSim. So basically, we have some assumptions, right? So the person's body is a circle, so that doesn't have a direction. So you will not get a like a different dimension in different directions. Uh, However, we assume that people can constantly turn their head, so they are aware of all the neighbors, no matter which direction they are.
Mhm.
Yeah.
Okay. Well, maybe this user can write to you and maybe explain better what he really needs
Yeah,
and
sure.
add it to the wish list. I think it's
Mhm.
also great to do these webinars because of the feedback you can get from potential users. One more question by Made Yutha. He says if you can track the time that each agent spent in the simulation and export it to an Excel spreadsheet.
Oh, yes. So let me see this example. So that basically is a grasshopper question, I think. But we have the basic component that allow you to do this. We have a person. Here we have person records. We have people. The people are live, are real time. So you can get people information from this component. You can have a lot of them, like position and body radius, velocity, acceleration, their path, and behavior, force, and movement state. Some of them you may never use, but in your question, you can get it here. It basically is similar to the one I highlighted, but it has the travel time. So it has a start time and end time. So you can get the total travel time in frames. The number is frame. Um, and you can get a series of positions. So let me see if I can turn it on in the map. Yeah, so here you can see, you can get a series of positions and you can connect the positions uh, like this. So you can see their way on the map. And from the time, you can do a simple math calculation and you can get a string. This is the total travel time. You can group them in the data structure you need and stream them to an Excel file, to a CSV file. Yeah.
Very nice. So actually, it's at the end, it's a Grasshopper function, no, exporting to Excel, but
Yeah.
you have all the parameters there.
Yeah.
Nice. One more question, this time by Danny Santoso. He asks if you can use PedSim not just as an horizontal simulation, but also with levels and elevation. So for levels and elevation simulation.
This one, yeah, we have been asked this question a lot of times. Unfortunately, the answer is no. We cannot do elevation change yet. It basically is a flat map.
Mhm.
You can, there are some way around this. If you, for example, I've done some simulation where we require to have basically an urban setting where we have maybe a courtyard case, and some people are on a higher ground, some people are on a lower ground, and you can set an obstacle, basically like the guardrail or something. You can use an obstacle to specify that elevational change so that people cannot jump over that obstacle, right? And in that you can do a 3D model of your obstacle, and when you see it on the top view, you will basically see a very similar effect, but you are still relying on a two-dimensional map.
Okay, thanks
Yeah.
for the explanation. What else? Yeah, Jimena Malerva asks if you can use this for a city. I think the
Okay.
principle is the same. Or
Yes, I think this may imply different requirements, different functionalities. I can imagine that the scale will be different and the number of agents will increase if you want to use it in an urban setting. So based on my test, I think the PedSim work best when you have like a fewer than thousands of people, maybe hundreds of people. That will give you basically real-time performance. But if you increase it to like thousands of people, maybe you will need to record your simulation as a screen capture and then play it back. Yeah.
so this is a hardware limitation.
It is a hardware, but we also have limited I think performance improvement space because we're relying on some functions and algorithms within the Rhino and Grasshopper. So sometimes we find it difficult to improve the performance to very much. We cannot improve it like 100 times to accommodate like 10,000 people and still do the real time.
Yeah.
Yeah. And
Okay.
also, I'm thinking that maybe in the urban scale, you will also need some other functionalities. I can imagine that maybe you will need vehicles, right? That that we have thought about it. For example, if you take a bus, maybe people are coming out of the bus in a batch, right? Like 20 people coming out together, and maybe for a long time, no people come out here. Yeah, that's something we are thinking about. Yeah.
I mean, that would be great. Yeah. Let's see next version of PedSim Pro. Okay, one more question by Erwin Ellin. He asks, or she, sorry, I don't know, if we can add some friction to paths, for example, to simulate slope or maybe uneven ground. I think.
Yes. I think I should say no because we don't have it yet, but it's we something we could add in the future. So that can be part of a series of functions. We can put them together basically to use some influence on the map that can cause people to change their speed or change some other things. Yeah. So the short answer is no, you don't have that yet. But
Not yet, but hopefully in the future.
hopefully, yes.
Okay. One more question. Nate Holland asks if there are any ways to simulate elevator wait times between floors.
Elevator basically, yeah, I think.
Wait times, so that is, I think, when it will open and people will start going out there. Or...
I think that's similar to the bus analogy. So we cannot do that yet, but elevator basically, if we ever implement the elevator, it will be similar to
the bus.
To the current target or a bus. Yeah. So yeah, we could do that in the future. Yeah.
So think in an elevator as a vertical bus, no?
Yeah. I think there are something we can do right now is the visiting time. For example, this information desk, you can control how long people will stay there, and for the final destination like this museum, you can control how long people will take to have their ticket checked. and disappear into this entrance. And you can also control like the frequency of people generating from here, from the
Okay.
entry.
Nice. More questions. Mark Rainbills asks if there is a way to manually create something close to people profiles in PedSim without Pro.
Without Pro, okay.
Yeah.
So,
So in
first,
PedSim,
let me just give you a preview of what this profile look like. So here you can see we have vision, we have the body radius, we have mass, we have speed, target force, damping, and these four are the time parameters that control people how they switch their target and how they switch their access point. Yeah. In PedSim Pro, we have some. In PedSim, we have some of these. We don't have all. We have vision. We have body radius. We have this target force. Let me switch back. So here, if you see this person template, we have this is body radius, this is target force, this is vision, right? We also have one time parameter, which is the time limit. When people reach this time limit, they will no longer go to any target of interest. They will just go to their final destination. Yeah, so this is the limited controls you have here.
okay, thanks. Another question, this time Christopher Polaski. He asks, are there a maximum number of points you can use? This seems very good for a master plan, but is there a maximum number of points between gates that are ideal?
Maximum number of points. Oh, I imagine you are asking about PedSim Pro. This right? The number of stops. I'll assume that. So no, you don't have a limit. So you can specify any number of stops, and even you can set the start and the final destination to the same point, so people can go back to their starting point. So basically, that is done through this. This is a series of stops. It is a list, so you can compose your list in any way you want. Yeah, it will follow this.
Okay, great. Then Priyanka Banusali asks if the pedestrian simulation for urban places with high public density is possible, or people in the transit. I think you answered this already, right, before?
Yeah. Since we have time, I will just quickly show this video. So this is some preview of a feature. So where we test a dense crowd. Here you see. So before, this is something new. We have the collision detection. Before we didn't have it, or even currently you still don't have it. People will overlap and experience large repulsion forces due to a large number of neighbors exerting force on them. But now with the collision detection, you can hopefully get a more stable crowd, and they can, even they're very tight, the behavior is still somewhat realistic, and they can get do this. They can get close to a door and try to force themselves in. In the meantime, it's stable. You can experience some reality with this kind of simulation.
Nice. So you develop yourself as well this collision detection?
Yeah.
Oh, nice.
So a good thing about PedSim is it doesn't rely on other libraries other than Grasshopper or Rhino. So you can just download this one plugin and you can get all these functions.
Okay. So you don't have to pay royalties to other companies. That's also nice. Okay, one more question. In this case, it's Utrecht. Can we commute it vertically like a ramp or like an elevated walking?
No, I think it's a similar question, but not yet.
Not yet. And Leila Pasandi asks, is that a way to validate it and simulate to use in a paper? That I don't understand it very good. is there a way to validate it and simulate to use in a paper?
Maybe it's
In
about
a paper, maybe it's a
researching paper.
exactly PhD or
Yeah.
but the
So
question is if you can use PedSim for a paper.
yeah, sure. I think sure. So, however, maybe you are expecting to have some something like this in a more in a better way
explaining the algorithm.
yeah, describe the algorithm in a better way. You can go to pedsim.net to see we are expanding our documentation, but for currently, I think we only list part of our algorithm. It's not fully disclosed yet. We hope to tell user more about how it's done, but we want to convey an idea. Basically, is PedSim and PedSim Pro. It's very simple. It's not as complicated as some of the research papers. You can expect maybe less social behavior, less complexity from the engine, but it should be very easy to understand, even without understanding all the formula behind it.
Okay. So Made Yudha thanks you for the webinar and for answering his questions, and says that it's really powerful tool in making data-driven decision at early stage. Thanks to you for attending the webinar.
Thank you.
Then there is one student that says that he will try the trial, the evaluation version. Yes, feel free to download it from food4Rhino. And Haman Kamal asks if it does work with irregular shape like curved walls.
Oh, yes. So I think a good example is here. I'm glad that I can use my limited examples to cover most of the questions. So here you can see it is a curved wall, right? The way we do it is by approximating it like this. You can see the red line is the obstacle.
Okay, so you need to discretize it somehow. Yeah. Okay, then Made also asks if PedSim Pro is based on Python or on C#, and if it's customizable with scripts.
It is based on C#. And script, I think right now, no, you cannot manipulate the PedSim code itself, but you can use Python in Grasshopper to extend it.
Are you planning to have an API, an open API?
Not yet.
Not yet.
Not yet.
You will have a lot of work after this webinar.
Yeah, please keep your feedback coming,
and that's
right.
Yeah,
we will try to address them. Yeah.
Okay, then Video Kuma thanks you again for the presentation and asks, have you validated the simulation using real-world observations of people, in particular in public spaces like streets, etc.? So if the data is real or not, I think he asks.
I think no. I think we are relying on our users to do that. Actually, if you can validate with your real simulation data and with your even your video recording surveillance or some other like cell phone data or metro card data, that will be great. You can publish it or share with us. We hope to have that information. Yeah.
Great. One more question. This time it's CalX6, and he says, perhaps I miss it, but is there a feature to simulate a group, like a family or groups of people?
No, you haven't missed it. We don't have it yet. We only do it agent by agent. So each person is a singular agent.
And then Nick Dodge asks if there is a way to use your plugin with Dynamo Revit without exporting your Revit model to Rhino.
We only have it in Grasshopper currently, not Dynamo yet.
The other day when we were doing a test version with Peng, I mentioned him that if he tries, most probably, if you try Rhino inside, Revit, then all Grasshopper plugins should work automatically inside Revit.
Yeah, they should work, right? I
They
haven't
should work.
tried that.
He hasn't tried yet, and maybe there are some.
After that, I actually tried one thing. I tried to use PedSim in Mac OS. PedSim can actually work in Mac OS.
Okay.
Yeah, so that's something we haven't developed in Mac OS, but it can actually work.
But well, for Nick, I don't know if you have tried Rhino inside Revit yet. We invite you to do it. You need to download the Rhino work in progress version, and then you can test existing Grasshopper apps to run inside Rhino, inside Revit, or inside Grasshopper, inside Revit.
Yeah. Please give it a try. Yeah, it will be nice.
Okay, and this is, I think, the last question by Farshad Askari. Hi, can we synchronize visiting time in PedSim with thermal comfort or other energy parametrics?
Synchronize. Let me think what you are asking.
Yeah, I'm not sure also about the question.
I'm thinking maybe by synchronize, you mean put them all in Grasshopper definition, right? And use some energy parameter as an input for PedSim.
Yeah, maybe that if it's too cold, there will be less people. If it's too warm, or depending where the light gives in your eyes, you will avoid that area. I don't know if that's a question.
Yeah. That's really interesting. That's a good question. So I think we haven't designed towards this yet, but I think it's a good idea to have some of the environmental data as an input within Grasshopper. Maybe you have a component that can take this input and use it to control the agents. That would be nice. Yeah.
Okay. And then we have some good feedback from Utrecht. Hey, McNeel, it was a nice presentation and it gives a lot of scope for urban design. Hopefully we can accommodate vertical movement also. Thank you. Nate Holland, advocator, says, yes, come on, PedSim plus Rhino Insight. And Nick also thanks you for this awesome presentation. And this was the last question or feedback. Many thanks again, Peng. It was a pleasure. I think it's a great addition to Grasshopper, and it gives the ability now to architects, engineers, and maybe in the future also to urban planners to have this kind of digital twins in movement, right?
Yeah. I also like to thank McNeel and thank Carlos. You are wonderful in terms of like developing such a great platform that are open and have so many functionalities that the developers can explore and build on. And that's great. And also, I would like to thank all the PedSim users. And please send us your feedback, and you can send email to the email address maybe Carlos will provide. And and please give it a try and tell us what you think. And we are open to new ideas.
Cool. As said in the beginning, this webinar will be in short available on our YouTube channel, and we will also add there Peng's contact details, as well as his YouTube channel and any additional information about PedSim and PedSim Pro. Hopefully in 1 or 2 weeks, there will be a new food4Rhino webinar. We will announce it one of these days. And again, thank you everybody for being here, for your attention, and see you soon. Have a nice day, nice evening, or nice morning, depending where you are viewing us. Bye-bye.
Yeah, bye.